Welcome back, students. This question is from GATE 2011 exam. They've given you these four circuits, the four options, and they're asking which of the following does not represent a XNOR gate. Okay, let us analyze them one by one. Before that, you need to know these formulas. Okay, I've provided you two such formulas in my theory lectures. One of them is noted down here, but you need to memorize both of them. This one is the formula for XNOR. Okay, so let us analyze option A first. We are having a XOR gate. Okay, and inputs are A, comma B. So here you will get a output A XNOR B, and then here it will be inverted. Okay, so whole complement. Now you very well know A XOR B whole complement will be A XNOR B. Okay, so option A is actually XNOR. Okay, there's no doubt this option is XNOR because it's a well-known fact that XOR and XNOR are complements of each other. Let's analyze this second option. What we are doing here is we are taking complement of one input. Okay, A is complemented using an inverter. Then it's given as an input to the XOR. Okay. Now using this formula, you can see complement A XOR B is A XNOR B. Okay, this one also represents the XNOR gate. How is this XNOR gate? For that, for proving this, I'll attach my video on a question of 2013 GATE exam. From that, you'll get to know more about this option B. Okay, so let us move on to option C. You can see we are complementing both of the inputs before giving it to a XNOR gate. So this part, this much, it will become A XOR B, because if you complement both of the inputs of either XOR or XNOR, it will have no effect. Okay, so this much is just A XOR B, or I must draw a line like this. Okay, yeah, so you can see next we are taking its complement. So A XOR B complement. So this is similar as option 8 of this question. This one is also XNOR. Now let's, I'll right now attach a clip where you'll get to know more about this one and this one. You watch it and then I'll just resume from here only. Okay. They're asking which of the following does not represent XNOR of X and Y. Now, you very well know formula for XNOR is X, Y plus X bar, Y bar. So option A actually represents XNOR. Okay, this one cannot be the answer. So let's analyze option B. Option B and option C are also representing X XNOR Y only. Okay, you can just see this formula. In my theory lectures, I provided you two formulas, one for X XNOR Y and one for X XOR Y. So the formula for XNOR is written here. From here you can see X XNOR Y is equal to X complement XOR Y. Also it's equal to X XOR Y complement. So B and C also represent the XNOR gate. Anyways, let's analyze these two. Option A, there's no doubt about it. It's the formula for XNOR. Okay. Let's analyze B and C. So option B is X XOR Y complement. X XOR Y complement. Let us expand it. You will get X complement Y complement plus Y double complement X, which is X bar Y bar plus XY, which is X XNOR Y. Okay. So option B represents the XNOR of X and Y. B cannot be the answer. Similarly, you can prove option C also represents the XNOR of X and Y. So I've used the formula. Let me write the formula also. A XOR B is equal to A bar B plus B bar A. Okay, this is the formula that I've used for expansion. Anyways, this option D does not represent XNOR. Okay, what does this actually represent? You can just verify it. It will be representing the XOR. Okay, XOR of X and Y. You need to memorize these formulas. So it is X complement XOR Y complement. X complement XOR Y complement. Let's open or expand this XOR. You will get A complement B plus B complement A. Okay. This is equivalent to X XOR Y. So option D actually represents the XOR of X and Y. But we want XNOR. Okay. So which of the following does not represent XNOR? That is option D, which is your answer. Now let's also prove it in one other way. I prefer that method because that's more intuitive. So we'll not discuss this one. This is a well-known fact. Option B says X XOR Y complement. Okay. Now XOR gate outputs 1 when both the inputs are different. On 0 1 or 1 0, it will output a 1. If both the inputs are same, 0 0 or 1 1, it will output a 0. Okay. The XNOR gate is completely opposite. If the inputs are same, it will output 1. If inputs are different, these two cases, it will output a 0. Okay. Now let's analyze how this one is XNOR. Say we are inputting same values of X and Y. When X and Y are same, the values that we input that are same, in that case, X and Y complement will be different. Okay, because X and Y were same, but complementing one of them will make them different. Now XOR on different inputs will output a 1. Okay, let me just write it. The values that we provided of X and Y were same. Okay, let's see what will be the output of this. Because the values of X and Y were same, X and Y complement will be different. And XOR on different inputs outputs a 1. So on same X and Y, we got output is equal to 1. Let's analyze what will happen if they are different. If X and Y are different, X and Y complement will be same. Okay, so if X and Y are different, in that case, the inputs to this XOR will be same. Okay, because X and Y are different, X and Y complement will be same. Now on same inputs, the output is going to be 0. In this case, the output is 0. Now you analyze this and try to conclude, is it XNOR or is it XOR? See, on same inputs, you are getting 1. XNOR also outputs 1 on same inputs. So this one can be linked with these two. Okay. And on different inputs, you are getting 0. XNOR also is similar on different inputs. It will give a 0. Okay. So this one is a XNOR gate. Similarly, you can analyze this option C. So we have already seen that answer is option D. Just bear with me for 2 more minutes. Let's discuss it in one more way. For XOR and XNOR gate, we just need to know this fact that are the inputs different or are they same? Okay. Like we don't need to know if the inputs are 0, 1 or 1, 0. By just knowing this much that they are different, we can declare the answer. In both the cases, answer is or the output is 1. Okay. So in option D, if I input different numbers, X and Y are different. So X complement and Y complement will still be different. Okay. That means complementing does not have much effect with respect to this gate. Okay. Had there been some other operator, this complementing would have effect. But in case of XOR, if both the inputs are complemented at same time, that won't have much effect. Let's discuss if both of them are same. That means the value that we input, X and Y, they are same. What will happen? X complement and Y complement will also be same. Okay, that means still there's no effect, because if the values were same, they were 0, 0, the output should be 0. But what complementing did is, it made the inputs 1, 1, but still the output is unaffected, okay? So it does not have much effect. So these bars, they can also be neglected, okay? So I hope you understood about these options. Now let's go to option D. This one is the standard circuit for X or gate, okay? You can memorize it, or we can just prove it. So I've given you 3 to 4 circuits for XOR gate. It is one of them, okay? Anyways, let's just prove it that this one is not the XNOR gate, and also it is the answer to this question. So A and B complement. This gate will output A dot B complement, because its first input is A, second input is complement B, okay? Then let's find output of this one. It will output B complement plus A, okay? Then you are inverting this and then ending it with this, okay? This one gate is an AND gate. Let's do that. Here you will get A dot B complement whole complement. Then this one is B bar plus A. It is B bar plus A. After that, you are taking AND of both these, okay? First input of this AND gate is here, and second input of this AND gate is written here, okay? Then you are performing a complement of this entire expression like this, okay? Now what can be done is, you can apply the De Morgan's law. So change this sign and split the complement. You'll get A dot B complement double complement plus B complement plus A whole complement, okay? This is what you are going to get. Now this double complement can be ignored, okay? And again you can apply De Morgan's law here. When you're going to apply De Morgan's law on this, what you will get is, this sign will be changed to AND, okay? And this complement will be splitted on both sides like this, okay? Now again you can ignore this double complement, and this is your answer. So it is A dot B complement plus B dot A complement. This is the XOR gate, which is equivalent to A XOR B, okay? So option D is your answer, because it's not representing the circuit for XNOR, okay?